To introduce our next speaker, let us welcome back to our screens Dr. Manapa.
Thank you very much. So after a very good talk, so we have another good presenter. No? It's always a pleasure to introduce her. No? She's one of the most hardworking member of the Philippine College of Swine Practitioners. She's a diplomate from the PCSP, and she's the technical consultant at Elanco Animal Health. Also the technical marketing manager from MSD Animal Health from 2005 to 2013. She was an assistant professor from the Department of Veterinary Clinical Sciences, the College of Veterinary Medicine at UPLB from 2000 to 2004. And we worked together. She was an epidemiologist, diagnostician from Animal Health Services from the Monterey Farms Corporation from 1997 to 2000. Her topic title for today is Challenges to Developing the Antibiotic Guidelines for Swine Practitioners. Let us all welcome Dr. Roselle F. Cudal.
Magandang araw sa mga kapwa kong veterinaryong Pilipino. Nagpapasalamat ako sa PVMA para sa isa na namang pagkakataon na maibahagi ang kaalaman at makapagbigay ng suwestyon para sa ikauunlad ng ating industriya. I will be sharing my insights on the challenges to developing the antibiotic guidelines for swine practitioners. Though I will be specific for swine, most of the issues and proposed actions are also applicable in most food animal species. In this talk, I hope to cover the following. We start with antibiotic use, especially in the light of antimicrobial resistance issues. I have consulted with experts to give specific details that is important in understanding. Then we look at the current guidelines that will help in veterinary use. Most are from international policy advising bodies. The importance of localization, so we address the current gaps for us here in the Philippines. Finally, we will look at the challenges that we will encounter as we go to developing antibiotic guidelines, especially in swine practice. The burning issue is antimicrobial resistance, and antimicrobial use has come into scrutiny because the assumption is that there is imprudent use of antimicrobials and not just antibiotics. So, the more we use them, the more we could further contribute to AMR. That is why awareness and surveillance actions are happening. Nevertheless, it is not clear that decreasing the use of animals will translate in decreasing AMR in humans. Take, for example, we know of the ban of AGPs and the heavy reduction of antibiotic use in Europe, but that did not stop AMR in humans. AMU in humans can be linked to AMR in humans, the same for animals. However, though this is the case, we are still taking action, which is the monitoring of the use of antimicrobials, and studies have started with antibiotics. This is to show by how much do we use antibiotics, especially in food animals. It is important that we take responsibility for our own practices and look at actions we can do as veterinarians. So this is part of antimicrobial stewardship actions. Though we are talking of antimicrobials, we are just starting with antibiotics. So most of the efforts and data being generated and the studies that are coming out are still focused on antibiotics. We need to address public perception. As I said, there are extremes in understanding. Some have no idea at all. And due to some ongoing campaigns which may be prejudicial to antibiotic use, some have gotten the idea that all antibiotics are not allowed for use anymore. As veterinarians, we may be called upon to address issues around AMR. And even among practitioners, there are questions that need to be answered. Can we still use antibiotics? For what purpose? What are allowed for use? What antibiotics are banned or not allowed for use in food animals? We will try to answer them in the course of this talk. Here we see the timeline of the discovery of different classes of antibiotics. The 1950s to the 1960s were the golden age of antibiotic discovery and declining since. No new classes of antibiotics have been developed since 1987. Since then, individual antibiotic molecules have been developed with modifications and adaptations to the existing antibiotic class. The objective of all these discussions is to preserve the efficacy of antibiotics. They are limited tools for us in addressing bacterial diseases, both for human and veterinary use. Let us look at what veterinary drugs, specifically antibiotics, are banned for use in food animals from a residue standpoint, not AMR. Because studies have shown that they can cause adverse effects to humans and animals, example allergies, plastic anemia, neoplasms, cancer, and toxicities. These lists are dynamic, and safety studies are continuously being done on other substances, so updates are necessary. We will look at three similar lists. First is from the FAO, the Codex Alimentarius, which lists the allowed maximum residue limits for antibiotics in food animals. There are certain veterinary drugs where there are risk management recommendations for residues. There are no set MRLs, and this means they are not allowed for use in food animals to avoid having residues in the meat. This is an international guideline, and some countries do their own assessments and come up with their own lists. Example, in the US, they still allow the use of carbadox in swine as a growth promotant, and safety studies are ongoing. In the case of the Philippines, where we do not have or have not done the necessary safety studies, we have instead adopted the FAO list, and it is in the Philippine National Standard. The PNS need to be adopted by the local regulatory agencies, and we see here that the DOH and DA have issued admin orders. These are the veterinary drugs in that list. We can note the specific antibiotics in blue text, which are banned for use in food animals here in the Philippines. This means any antibiotics not listed here are allowed for use. I am showing here a list of antibiotics. This is largely based on the OIE list, which provided the animal species usage. We'll also note the colored boxes where we checked which ones are available in the Philippines. We use the PVDR and PVET listings. We also asked for a list from the FDA, which we assume would already include the ones from the BAI. You will also note that some of them have no colors because we got some of them from the list provided to us by the FAVA and the FAO. The survey will be shown later. In bold letters are the antibiotic classes. Some of them are not available in the Philippines, but most of them are. We have here the aminoglycosides. We have the cephalosporins, first, second, third, and fourth generation. The ionophores. Interesting for the ionophores, they are considered antibiotics in the US, but in Europe, they are actually classified as anticoccidials. So they are not antibiotics, but antimicrobials. And of course, we have the lincosamides. We also have here the macrolides, which are also either 14, 15, 16, or 17 membered. Apologies to those that have not been indicated here because we need still to update the new market entries. And of course, we have the orthosomycins, the phenicols, and the plurimutilins. In this list, we have the penicillins, the polypeptides, and the quinolones, which has first and second generations. We have the diaminopyrimidines, the streptogramins, the tetracyclines, followed by the sulfonamides, and with their combinations with the diaminopyrimidines. Last, you will see the antibiotic combinations available as listed in the FDA. We have not reviewed the listings of PVDR or PVET for this. Most are combinations from different classes of antibiotics. These would be supported by synergistic studies and are combined for the purpose of broadening their spectrum of efficacy. The list given by FDA included those for human use. Now let's focus on resistance. There are two types of resistance. Intrinsic resistance, which is naturally occurring resistance of the bacteria due to the absence or inaccessibility of the antibiotic to a drug target. While there is also acquired resistance, which is the resistance developed by the bacteria to an antibiotic drug that was originally effective at treating infections caused by it. Questions arise that would need some explaining. How do I know bacteria is resistant? What can I do if it is already resistant? What can I do to avoid resistance formation? We will try to answer them in the following slides. Let us review a bit to explain why there is resistance formation. An antibiotic has specific targets for each specific bacteria. Note the red text, which are specific structures and mechanisms on bacteria where specific antibiotic classes in black text have an effect. Depending on their effect, which is either outright to kill, bactericidal, or to stop replication, bacteriostatic. These are mode of actions of antibiotics that are extensively researched before an antibiotic is marketed, and the information is seen on product labels. Ideally, we should follow the indications and avoid off-label use. Of course, there are field studies that are done once the antibiotic is on the market, which may expand its usage, and that is why we need to update. However, there are certain bacteria that have intrinsic resistance, naturally occurring resistance of the bacteria due to the absence or inaccessibility of the antibiotic drug target. A good example would be mycoplasmas. Since they have no cell wall, they are intrinsically resistant to beta-lactams whose action is on the cell wall. Your doctors and veterinarians are well aware of this. This is why diagnosis is very important. Knowing the bacterial pathogen so we can choose the right antibiotic for it. Now, when an antibiotic is prescribed and given to the patient or the diseased animal, we are aiming to kill the bacteria to resolve the problem. However, every living thing wants to survive, and bacteria will fight back. If exposed to antibiotics, they will try to develop resistance mechanisms. You see here in red text. And in black text, you will see the antibiotics that bacteria have developed resistance against. This is acquired resistance. Resistance developed by the bacteria to an antibiotic that was originally effective at treating infections caused by it. That is why this is the resistance that we are referring to in AMR surveillance studies. And that is why authorities are doing surveillance and monitoring to look into acquired resistance patterns. Veterinarians also need this information to decide on their therapeutic decisions, like should they be rotating antibiotics or perhaps shift to another antibiotic class to manage any resistance formation. How does antibiotic resistance occur? Antibiotics will kill most of the harmful bacteria it is targeting, but there are times when it cannot kill all. Can you think of an instance when this can happen? In humans, they have identified underdosing, or when doses are not finished by patients, like being prescribed for 7 days and you take only 3, and this can lead to resistance formation. Let us not forget that if we also do not diagnose correctly, we could be using an antibiotic to which the disease pathogen has intrinsic resistance. The more sensitive bacteria are killed off early, but because the full regimen is not finished, the rest of the bacteria could already be acquiring resistance. This is when we see new strain development, when the bacteria have the genetic changes that give them the resistance, and most of the research nowadays is focused on identifying and monitoring this. These resistant bacteria will be able to spread their resistance to other bacteria by gene transfer. Here are some added information, terminologies that you will encounter with resistance studies. Cross-resistance is when that resistance mechanism confers resistance to other antibiotics of the same class. while co-selection is when the genes conferring resistance to different antibiotic classes are found on the same piece of DNA, or it is co-resistance if they are not genetically linked together. Unfortunately, the resistance can be multiple. So in the case of antibiotics, there could be the rise of multi-drug resistance or MDR bacterial isolates. It is the acquired resistance to at least one agent in 3 or more categories. There are also extensively drug-resistant bacterial isolates. So the acquired resistance is in all but 2 or fewer categories. This means the options have become even more limited, and the bacterial isolates is now only sensitive to only 1 or 2 categories. And what we do not want to happen is a pan-drug resistant bacteria, where the acquired resistance is already to all antibiotics in all categories. Now, there are caveats. These are laboratory results and should always be interpreted with caution, as these may not be reflective of clinical or field efficacy of the antimicrobial. So veterinarians' field experience in treating diseases in herds and previous treatment records are also useful references. We have established that we are looking specifically at acquired resistance. The question that follows is, how do we know that resistance is developing? What are the tests done? What are the parameters being monitored? And how do we say that resistance is already a big concern? First, we have the government-led AMR surveillance programs. It involves the collection of samples from healthy animals, also from diseased animals, from aquaculture and environment. And there are 4 bacteria, which are enteric or intestinal and commensal bacteria, and these are the ones that are being isolated as their antibiotic resistance results can represent for classes and resistance genes. This type of surveillance is done over time in a certain population or area, and the samples are collected, bacterial isolation done, and then the isolates are exposed to different concentrations of different antibiotics. In this picture, we have the broth dilution test, and the result will read as MIC or minimum inhibitory concentration. This is the lowest concentration of an antimicrobial ingredient that prevents the visible growth of bacteria. However, of concern to us as practitioner veterinarians is the question of, is the drug I am prescribing for an animal still effective? This is when we submit samples to the diagnostic laboratory to determine that the bacterial disease pathogen may be causing enteric or respiratory infection. Some laboratories will then use the antibiotic sensitivity test done on agar plates, where the zone of inhibition will tell us if it is a sensitive, intermediate, or resistant bacterial isolate. All practicing veterinarians are familiar with dealing with clinical breakpoints. These are standard to each antibiotic for each disease pathogen and are used to predict whether an antibiotic will be clinically effective against a particular bacterial isolate. They are based on a combination of MIC values, pharmacokinetic pharmacodynamic values, and clinical outcome data. This is what the diagnostic laboratory will be giving as a result after the antibiotic sensitivity test. It is the percent sensitivity or susceptibility that will help the veterinarian decide on his therapeutic decisions for the herd. Now, I have shown this table before. This is an example from a diagnostic laboratory, and on the x-axis, you will see all the bacterial pathogens isolated in the lab for 2019. On the y-axis, you will see the antibiotics they use for their antibiograms for sensitivity testing on the isolates. You will note that aside from the percent susceptibility, there is also a number of isolates inside the parentheses. We must remember that we veterinarians have the knowledge that we are guided by product labels to know which are intrinsic and acquired resistance. Let me just repeat my example from last year's talk, which is specifically on telmicocin. There is acquired resistance that can be developed to the ones in the label, which could be APP here and Pasteurella maltosida A, and that's important to monitor. At the same time, we know that the 0% here are natural because they are intrinsically resistant. Now, it has always been my hope that we increase the number of veterinarians sending samples so our diagnostic laboratories can consolidate their data so we can have Philippine-specific information, and we veterinarians can benefit from the information. We need to have improved diagnostic laboratory capability. It's very critical for veterinarians to diagnose the disease. And if there is confusion on the bacteria being isolated and the AST results, the basis of therapeutic decisions may not be correct. In this example, we follow a veterinarian as he sends samples to the laboratory. His concern is he is treating elytis with tylosin that needs to be assessed. Unfortunately, Lawsonia intracellularis is one of the bacteria needing specialized microbiological techniques, and the laboratory is only able to isolate E. coli. The antibiogram on the E. coli isolate shows resistance to tylosin. And actually, this is intrinsic resistance. This is then the basis for the vet to change his therapeutic decisions. Ito po talaga ay nangyayari. And we hope that our laboratories can invest in enhancing their capabilities for isolating the following swine bacterial pathogens which actually need specialized methodology. The interpretation is different in AMR surveillance programs. We use as an example this data set from the EU. This is not from surveillance data, but I will use this to help us in understanding the data we could expect to get and how that data is interpreted. We see the MIC results of 152 E. coli isolates to several antibiotics used to treat it. The percentage resistance is used to determine if the resistance is already a big concern. From this table, we see the high levels of resistance to tetracycline for E. coli, as it is the most widely used antibiotic in pigs for both enteric and respiratory infections in the EU. In the book, it also explains that in the US, E. coli clinical isolates have resistance to other different antibiotics, and this is again reflective of what is available for them. The question is, what will our E. coli isolates from our own national AMR surveillance program show? Will it also reflect the usage of what we have available antibiotics? This is the importance of having our own local data. We see then that the next question aside from percent resistance is, how do they determine that percent resistance? How the MIC results are interpreted can vary. National surveillance programs do not all define resistance in the same way. They may be using the same parameter, but different cutoffs. These country reports will often use epidemiological cutoff values to determine if the percent resistance values are already a big concern. Again, we use the data from the example from the EU, MIC results of the 152 E. coli isolates, and specifically looking at resistance to amoxicillin. The percent resistance isolates are plotted out to their specific MICs, and the epidemiological patterns are analyzed. These cutoffs can be changed. In this case, only the isolates at MIC 128 is considered resistance, so that is why we get 43% resistance of E. coli to amoxicillin and 0% for amoxicillin plus clavonolic acid. Will that be enough to make policy to affect availability or restricting amoxicillin use? What if they move the cutoff? And so interpreting such reports must be done with a caution and changes in breakpoints noted. It is always ideal for each own country to generate AMR data, and experts have to be consulted so we interpret the data according to our local context. These data can then be the basis for crafting of better policy options and not just collecting to say that there is surveillance. This would ensure the public that government is creating policies based on evidence. It is also important that all aspects are considered and that risk assessments are being done with stakeholder agreement. Why do we talk about minimizing risks? Antibiotic resistance is a naturally occurring phenomenon, but it is influenced by many factors. Problems related to development of resistance are inherently related to use in any environment, including human, animal, and even plant use. The use of antimicrobials have led to the selection and dissemination of resistant microorganisms, which results to a loss of therapeutic efficacy in both animal and human medicine. So, we always look at ways to lower the human and animal health risk associated with their use. This is why the OIE has advocated the use of risk analysis methodology even for this issue with antibiotics. We go back to the objective of preserving the efficacy of antibiotics, and so the question will be, will the use of antibiotics in animals pose a risk for human health? The components of risk analysis are hazard identification, in this case that would be AMR, and then risk assessment, risk management, and risk communication. We want to lower the risk posed by the hazard of AMR, and this risk analysis suggested by OIE to its member countries will provide a transparent, objective, and scientifically defensible method of assessing and managing both human and animal health risks. Now, for both human and animal studies that will provide data on release, exposure, and consequence will be needed. The question really is, who will be responsible for these activities? And will the government have the money to spend on risk analysis studies? And how can the industry help? Either way, this is what we really need right now to clarify all the issues around antibiotic use. In making a risk assessment, a hazard is identified. In this case, it is a bacterial isolate which have acquired resistance arising from the use of a specific antibiotic with consideration to its class or subclass. In the release assessment part, it will describe the probability on how and what are the factors in which the antibiotic use in those animals resulted in the emergence of resistant bacteria. So data such as antibiotic use, what are the farm systems, what led to the lack of efficacy. It will also include the data on the development of resistance and the mechanisms of resistance transfer. So all of these studies are ongoing. In the exposure assessment part, it will include the biological pathway into how a person ingests meat from treated animals that is contaminated with those same antibiotic-resistant foodborne bacteria. Data such as human demographics, what is the microbial load in food at the point of consumption, did that contamination come from the feed or is it coming from the environment? In a consequence assessment, this part needs collaboration with our human counterparts because this determines if the person did ingest this animal-derived antibiotic-resistant bacteria and they became sick with a bacterial infection that cannot be appropriately treated with antibiotics. This is why it is important for us to get our own local Philippine-specific AMR surveillance data in place so we can assess our own risk based on our own local context. If the risk is established, only then can we recommend that this antibiotic be restricted for use in food-producing animals. Decisions around the use of antibiotics, especially for therapeutic means, must be under veterinarians. This is the basic premise of veterinary oversight. Farmers should not decide to use antibiotics without consulting a veterinarian, and it should be covered by a prescription, which is our veterinary drug order. Sadly, there is low compliance to implementing the laws on VDO and the VCPR. The use in human medicine has been largely controlled by good prescribing and dispensing practices. You cannot buy antibiotics from the pharmacies if you do not have the prescription of your doctor. Such is also the system that we must have as veterinarians. It is already the 89th PVMA convention, and I look back at the 85th when we in the Council for Biologics and Therapeutics decided to make a paper on reviewing and promoting the VDO and VCPR. We even proposed a format combining both VDO and VCPR. We also reviewed the process as described in our law, realizing that the paper trail was tedious and that contributed largely to the non-implementation. I know for a fact that both FDA now holds the registration for all active veterinary medicines and the BAI, which will be specifically looking at feed medication, are crafting new administrative orders to strengthen the implementation. And to ensure that it will go well, we should all look at examples ongoing with human doctors and pharmacies, and even in other countries, because they are able to strictly implement and automate the process. Other countries have already instituted websites, and veterinarians can even use mobile apps to log in their prescriptions. This will be the answer to ensuring that we have veterinary oversight on antibiotic use. Without the system in place, it will be difficult. If we are to contribute to the effort to preserve the efficacy of medically important antibiotics, we practicing veterinarians must support this, but we also need a working system by which to do it. I know that the PVMA is working closely with our regulators to make this a reality. I mentioned about regulatory disallowing prevention use, and these have come about since there are differences in definitions. The wording and emphasis varies between how the WHO defines use. The WHO combines both prevention and control in their definition, while the FAO and OIE actually define these separately. We also see that both the WHO and FAO use the term prophylaxis, while only the FAO uses metaphylaxis. This is why it is critical to have a clear definition set for us in the Philippines and agreed on by all stakeholders so we can avoid misconceptions. Next, we need to understand that in the context of AMR, there is now antibiotic categorizations. The term medically important antibiotics refer to antibiotic classes that are important in human medicine practice, though the bulk is shared with veterinary use. Because public health is a primary objective, this is the one where we need to preserve antibiotic efficacy because these are used in human patients. You can see this list in the WHO. In the non-medically important antibiotics are those antibiotic classes which are not used in human medicine and are actually used in animals only. We will not see this in the WHO list, but you can see them in the OIE list. This is the WHO list of medically important antimicrobials. It categorizes antibiotic classes and generations into critically important, highly important, or important antibiotics. There are also further prioritizations. This is usually updated based on AMR data. And this is an international guideline, and other countries have made their own categorizations of their own antibiotic lists. In a separate document, the WHO guidelines on the use of medically important antimicrobials in food-producing animals, they have been drafted by human doctors, and the OIE was not able to contribute, so it means it is only meant to potentially protect humans without taking into account the need for veterinarians in the care for animals. So let us look more closely into these suggestions. In the orange bars, we see that the WHO suggests that all medically important antibiotics will be reduced in usage and not to be used in prevention or as AGP. This brings us to a realization that since there are animal use only antibiotics and they are not under AMR scrutiny, so they can still be used as AGP. This is an interesting point that we have to discuss with our regulators because this is actually being done in other countries. Now, in the yellow bars, These are the one that HAO identified as high priority or highest priority, and they are suggested not to be used for control or treatment in food animals. With these suggested restrictions by the WHO, I often hear comments in webinars involving the tripartite, WHO, OIE, and FAO, that the WHO list is unfair to veterinarians, and I agree. What then can we use as food animal veterinarians? Countries would do well to gather their own AMR data and categorize antibiotics according to their own risk assessments. There are several interpretations to the WHO's critically important antibiotic list, and it is very varied. This is a screenshot of a speaker slide from a tripartite discussion. It is a comparison given as to how the OIE and FAO interprets the WHO list. We see that the WHO list is very restrictive, with only the critically important antimicrobials which could be used for treatment and the rest not. However, the OIE list clarifies the need for veterinarians to have tools as well for therapeutic use. The counterpart guideline for veterinarians is the OIE list. We see here the categorization of antibiotic classes and generations into veterinary critically important, highly important, and important antimicrobial agents, though again, most are still antibiotics. Veterinarians need antibiotics as tools to combat bacterial diseases. If animals are sick, it is in our oath to treat them and stop their suffering, for it is an animal welfare issue. You realize that there is indeed a need to harmonize the WHO and OIE list. There are a lot of overlaps in the classes. The WHO list is followed by most companies to guide vet use, but is very restrictive. The OIE list provides context as to what veterinarians need for their therapeutic decisions. But these are international guidelines, and there is a need to localize so that actual national policies can be adapted to local situations. We also need to appropriately balance animal health and public health aspects. Our human doctor counterparts get guidance from the DOH with the issuance of the Philippine National Formulary. You will note that they have already incorporated AMR into consideration when they updated their list. As an example, amoxicillin includes a categorization from WHO, which is access. This means our government has adopted the WHO classification of access, watch, and reserve. On the other hand, we are yet to update the veterinary formulary. In this list, we see that all antibiotics are under prescription, and we know that we have other popular and updated industry lists also available for veterinarians. But all these lists will only tell us what product labels give us. We need more guidance on how to mitigate the risk, which includes being more responsible in the use of antibiotics. There is also a need to formulate a harmonized antibiotic classification between human and veterinary use. So we swine veterinarians can do responsible use. It has been proposed in a statement that reads, as a veterinarian, you have to get the right diagnosis, use the right drug, in the right amount, by the right route, for the right period of time, through the VDO and VCPR. We do need a guide since the AMR data and antibiotic categorizations are often not available to us. So a practical example is given. Swine veterinarians are equipped with skills to diagnose by clinical signs, and they can recommend a first line of treatment and even institute a clinical approach. However, if the disease outcomes are not as expected, example, the percentage of animals morbid or mortalities increase, it is often necessary to do a laboratory confirmation, bacterial isolation, and antibiotic sensitivity tests to determine if the antibiotic use is still effective and bacteria remain susceptible. If there is resistance development, a second line of treatment may then be instituted. So what we need are antibiotic guidelines. Our human doctor counterparts have already developed their antibiotic guidelines, and they are guided by AMR data. The main objective is to provide treatment options for human patients for each particular bacterial disease. So you have the disease with the identified causative bacteria and treatment options. We need to start developing our own veterinary antibiotic guidelines. It will be the same in essence, and it is each important swine bacterial pathogen which need to be identified and the therapeutic options laid out. Let us start with understanding what are antibiotic guidelines and how they are made and what is their purpose. The purpose is to support veterinary oversight and promote therapeutic use. As we discussed earlier, it will also need a working VDO BCPR system. It will serve as a guide for practitioners. It is not policy, and vets will not be reprimanded if they do not follow. Data to be included and decisions will be evidence-based, if possible referring to peer-reviewed research. Findings will be considered and critiqued, and guidelines adjusted as we see appropriate to the level of confidence we have in the research completed. Where evidence is lacking, recommendations are then based on human literature and expert opinion. The process in making it should be collaborative and independent with no conflicts of interest. The PVMA, with its specialty colleges, will have a big role to play in developing these guidelines. Here is an example from the Canadian Veterinary Medical Association. I would like to thank Dr. Agnes Agunos for providing this. Specific to swine meningitis, pneumonia, and arthritis caused by Streptococcus suis, first we see a list of injectable antibiotic options. We see the antibiotic molecule, the dose, the route, and the duration of treatment. The next column gives us the veterinary drug category based on importance in human medicine. We see the Roman numerals 3, 2, and 1, and this means that the veterinary use considered human use efficacy. So by order of lesser importance to human practice, we see the order of antibiotics. In the last column, we see comments, where recent sensitivity data are indicated. In this next page, we see the options for in-feed and water antibiotics. And note that the extra label use is allowed since there have been efficacy studies done. This is where veterinary practitioner feedback is important since we are the ones to use and monitor and evaluate the efficacy, so we can provide updates with this type of studies. This is a very dynamic document. Updates can be done as soon as new and relevant data comes out. Other swine diseases included are listed here. So now that we are seeing this, if we are going to proceed in making our own antibiotic guidelines, we see here the elements that we need to put together. Last year, during the 25th Pinoy Pork Challenge, the PCSP was requested by the Philippine College of Veterinary Epidemiologists to conduct a survey among the participants. I would like to thank Dr. Mel Umandal for allowing me to share this data, to Dr. Mike Kilitis for coordinating the survey. We got 320 responses who were asked to list their top 10 important swine diseases. This is a mix of viral, bacterial, and parasitic diseases, and isolating the bacterial diseases and ranking them, we get this. So we have APP, Actinobacillus pneumoniae, enzootic pneumonia, Glasser's disease, other mycoplasma infections, Streptococcus suis, E. coli causing MMA, E. coli causing gut edema, Salmonella cholerae suis, atrophic rhinitis, leptospirosis, and erysipelas that came out in that list. Another survey conducted last year by the PVMA under the umbrella of the FAO and FAVA was on priority bacterial pathogens and antimicrobial for antibiotic use in the Asia-Pacific region. We see in this survey was participated by the 10 member countries of the Federation of Asian Veterinary Association, and it covers 4 food animal species. I have been given permission by PVMA President Dr. Lino Abad to share the swine-specific responses from the Philippine respondents. We had 52 respondents, of which 50% are field veterinarians. Their job roles Mostly were on treatment decisions and field clinical differential diagnosis. In the survey list provided by FAVA, we see 9 common swine bacterial diseases, and you will note 4 comments per disease. The blue bars were those commonly encountered in the field, and the highest scores went to enzootic pneumonia, pasteurellosis, scars by E. coli, and Glasser's disease, followed by pleuropneumonia, atrophic rhinitis, and meningitis. Low scores for erysipelas and septicemia. The red bars were the bacterial pathogens isolated in the laboratory, the highest being E. coli, followed by Pasteurella multocida. The orange bars were diseases that caused significant economic loss to racers. Highest would be pleuropneumonia, followed by scars, Glasser's, and enzootic pneumonia. The green bar, which is asking if the disease is difficult to treat, we can see that all diseases have low scores. This means that veterinarians and farmers have access to antibiotics to treat the infections. In addition, the survey also asked the respondents to list other swine bacterial diseases that are important, and we see here some suggestions. In this survey, the respondents were asked to list the most commonly used antibiotic for each swine disease. This data is for pleuropneumonia, and tilmicocin has the highest percentage. The other higher percentage choices are amoxicillin, ceftriaxone, and florfenicol, and we see at least 3 antibiotic classes being used for such cases. On the right side, the pie chart shows the second most commonly used antibiotic. In this case, it is ceftriaxone and the same molecules with the addition of enrofloxacin, which is another antibiotic class. In my opinion, the veterinarian has a wide variety of therapeutic options for APP treatment, control, and prevention. This will be the way the data will be presented in the next slides. For atrophic rhinitis, most common used is amoxicillin. Second most common for such cases is ceftriaxone. For erysipelas, most common use is amoxicillin. Second most common use is ampicillin. You will see that the top choices are all parenteral beta-lactam antibiotics, which could become a concern. For scars caused by E. coli, most commonly used would be colistin, followed by amoxicillin and apramycin. Second most common would be the antibiotics, same antibiotics with the addition of enrofloxacin. For Glasser's disease, most common use is amoxicillin, followed by ceftriaxone and enrofloxacin. Second most common would be the same antibiotics with the addition of florfenicol. For enzootic pneumonia, most common use is thiamulin. Second most common use for such cases are tylosin and telmicocin. For pneumonic pasteurellosis, most common use is amoxicillin followed by ceftriaxone. Second most common use are amoxicillin followed by doxycycline. For septicemia caused by Salmonella cholerae suis, most common use antibiotic is amoxicillin followed by florfenicol and trimethoprim sulfa. Second most common use would be amoxicillin followed by enrofloxacin. For meningitis caused by Streptococcus suis, which is a zoonotic disease, most common use antibiotic is amoxicillin followed by ceftriaxone. Second most common are the same with the addition of 2 other beta-lactam antibiotics. Here is a summary of the top choices for most common and second most common choices for antibiotics. We see that amoxicillin is the choice for most swine bacterial diseases. We ask ourselves the question, what is the risk of becoming resistant for this? So it would be interesting to have our own local bacterial isolates and our own local laboratory test results. That is a lot to take in, and I hope you will start thinking about it. If we are to develop and make a dynamic Philippine-specific antibiotic use guideline for food animal veterinarians, malaki ang maiaambag ng veterinaryo dahil feedback ng mga practitioners ay kailangan. We will definitely need to consult experts to guide us, and we should consider the implications for public health and animal health, as well as the influence of existing regulations. We come to the end of my sharing. To highlight the important parts, we looked at the banned and allowed for use antibiotics. We differentiated intrinsic from acquired resistance. We reviewed the tests and the different results interpretation for AMR surveillance in contrast to disease diagnostics. We talked about risk analysis as a mechanism to evaluate the AMR issue. We looked closely at antibiotic use definitions and the issues therein. We highlighted the need to make VDO and VCPR implementation better, and we took a look at the WHO and OIE guidelines, realizing the need for harmonization. We also looked at the need for localization, and we noted that the DOH has already started with their guidelines. We were able to clarify the purpose and content of the antibiotic guidelines we hope to develop, and we looked at the CVMA prudent use guidelines as an example to understand the elements we need to put together. And along the way, we saw the challenges we could encounter. We are fortunate to note that there is data to start on, as we presented the two surveys for bacterial disease prioritization and what is commonly used antibiotics. I hope I was able to provide more clarity on these discussion points. Sana po nakadagdag sa inyong kaalaman para sa veterinaryong Pilipino. Maraming salamat po sa inyong interes.
And for our second Q&A of the evening, let us call back Dr. Manabat and Dr. Roselle Cudal to answer some questions from our attendees.
Dr. Roselle,
Hi, Doc.
very insightful presentation. No? Ang dami na nagtatanong. So let's go through it. No? So let's get the first question from
Sure.
Dr. Alice Bungay. In
Mm.
some parts of the globe, extended spectrum beta-lactamase producing Enterobacteriaceae are increasing. Are we seeing the same trend in the country among our pig farms?
Hindi lang ikaw ang nag-Google kung ano ang ESBL, Doc
Oo,
Angel.
pareho tayo, di ba? Mahirap naman, hindi natin yung ESBL, di ba?
Disclaimer po, ako po ay hindi microbiologist. Minsan lang po ma-involve sa research o swine practitioner kami po. Kami yung more on gumagamit ng research data na. And thankfully, there are some researches that have been done in the Philippines. And thank you to Doc Caroline Benigno who sent me the paper of Dr. Gundran from 2020, Prevalence, Antibiogram, and Resistance Profile of ESBL producing E. coli isolates from pig farms in Luzon. Fortunately, it is in Luzon. And the percentage, if I'm not mistaken, is 57.4%. Quick look at the abstract. So there are studies, but what we would like to point out more is that kulang pa po yung data. Kasi sa Luzon lang yon. So sana may gumawa din sa Visayas, sana may gumawa din sa Mindanao, and sana i-publish po nila para po magamit yung data. So kaya I'm a big salute to the researchers out there, and thank you, Doc Alice, for the question. Ayun po, Doc.
From Doc Alice, no? Would the development of AMRs vary depending upon the specific ages of animals? So for example, 3 weeks old, weaning stage with higher number of E. coli. This could be explained by the diversity of microbiome which shift over time of production stages. So ano to comment mo doon?
Hindi po ako ganun ka maalam, pero ang pag-understand ko po dito, other regulatory authorities have mas strict sila dun sa grower finisher stage kasi more on pinagbibigyan nila na magkagamit ng antibiotics yung nasa weaning stage kasi stressful pa yung condition doon. Now, as to whether the microbiome picture at that time makes them more, resistant, pwedeng yes, it could be possible kasi nakikita natin yung mga data, but unless we do the risk analysis at that point in time, hindi po natin ma-determine talaga. Again, sorry, hindi po ako microbiologist, but interesting question, Doc Alice. Thank you.
Thank you, Roselle. Dr. Randy Galutan asked, "Thank you, Dr. Cudal. We really enjoy learning from you. We are with you with responsible use of antibiotics. But antibiotics are easily bought from Lazada and Shopee. What can we do about it?"
What indeed can we do about it? The PVMA is actually doing, I think, advocacies for this. Meron po tayong council on biologics and therapeutics, and you can maybe submit a complaint form. So, nandito naman po ang PVMA for this. And of course, para po ma-elevate yung concern sa mga concerned authorities po natin. Kasi yung mga authorities po natin, ang may kakayahan na mag-act po sa mga ganitong concern. I am with you on this concern kasi even sa Facebook po, nakikita ko rin po na nakakabenta sila. So, very concerning, no? And dagdagan pa natin, Doc Randy, syempre yung ating mga mga kaibigan na agri-vet supplies. Wala po yung ang prescription and dispensing po ay hindi rin po nagagawa. So, marami pa po tayong dapat gagawin. And I think one solution for this is really the implementation of the VDO VCPR system. Yan po.
Marami tayong kailangan gawin. From
Marami pa.
From Dr. Rolly Carnacion, is it recommendable based on your experience with AMR phenomenon? Can we support and advocate the use of comparable phytogenic and phytochemical feed additives and liquids used in food animals for the prevention and control of both bacterial and viral infections?
Yeah, that's a very good question, no? Kasi usually kasi ngayon yung mga prebiotics, probiotics at saka itong mga ibang phytochemicals, ang kaya nilang i-replace easily na use ng antibiotics is the AGPUs. So, hindi ko na siya diniscuss kasi last year, diniscuss ko na yung use definitions. Pero the AGPUs is the use of antibiotics to improve weight gain and improve feed efficiency. However, treatment, control, and prevention are therapeutic uses. And naka-attend po ako ng isang convention, kasama ko doon si Dr. Talud. So, Dr. tulungan mo ako. Pero natutunan namin doon na hindi pwedeng mag-claim ang mga alternative supposedly if wala silang specific mode of action na kaya nilang ipakita na nakakapatay sila or nakaka-inhibit sila ng replication ng bacteria, which is what an antibiotic does. So, hindi ko alam kung meron na, pero during that time, wala pa pong yung mga candidate of being alternative na nagkaroon ng mode of action for therapeutic use. But for AGP use po, opo, pwede po. Hope that clarifies.
Thank you, Dr. Roselle. So basically, does the industry, do you think, do we have enough proven alternatives to antibiotics, Dr. Roselle?
I think for now po, wala po.
Antibiotics?
Wala po talaga in the strictest sense na kaya niya yung action ng antibiotic to kill or inhibit the replication. So, yun po yung nagiging concern natin. But the AGP use po, kayang-kaya pong i-cover ng iba.
Another one from Dr. Alice. Some studies have suggested a link between animal and humans for transmission of certain Staphylococcus aureus clones. So what can you say about this?
Ang alam ko lang po, Doc Alice, pag nagkatabi-tabi po yung mga bakterya, meron po silang mga gene transfers. Meron po silang mga sex pilus, no? They exchange this genetic material. So yes, it could be possible, although I do not have a specific study that I can cite. But I would say yes. Basta kaya palaging ang sa atin, sinasabi sa atin, maglinis tayong mabuti. 'Di ba? Clean and disinfect, good husbandry practices kasi ayaw nating mag-abot-abot yung mga bakterya doon at they mingle together. Magkaroon sila ng Valentine's date instead na wala sila, they don't come in contact. So, let's avoid this because it is a possibility. Yan pa.
Dr. Roselle, natanong lang si Dr. Ferriol, no? Sabi niya, doon sa list mo daw of approved drugs, roxarsone was still approved in the use in the PH. He's trying to clarify.
Yes, sorry, no? Mabilis yung ganun ng slide. If you want a copy of the list, I can provide you. But yes, wala siya sa PVET at PVDR, pero nasa FDA list siya. So, hindi lang siguro nag-advertise kayo sa PVET at PVDR. Pero approved for you siya based on the FDA list. Ayun po.
Okay, isa pa from Dr. Alice ulit. Is there a possibility of reversing the effects of antibiotic resistance about using gene silencing technologies?
Ha, Doc Alice, hindi ko kaya. Nosebleed ako. Baka
Hahanapin po
pati
natin
kami
yan.
turuan mo niyan. Bakit pwede bakit hindi ano no kasi nga nasa genes kasi yung ano yung
Yeah,
pagiging
yeah.
resistant nagkakaroon sila ng genes. Ang alam ko po may iba na sinasabi nila na i-demedicate nila, yung alam mo yon tatagalin, mga toxin binder ginagamit nila para ma-absorb lahat ng antibiotic para ang purpose naman ay walang residue sa dulo. Okay, so isa yon. Para lang ma-reverse, kumbaga, part of the mitigation. But this specific one, this is very unique. Napa-Google din ako, pero wala akong nakita.
Thank you. From Dr. Rosario Bagos. In livestock, we have video VCR. In comparison, and in companion animal, we have prescriptions. So my question is that who will implement and police these laws? No, where in fact now drugs not only OTC but other prescription drugs and even anesthetics are available online. Same question kanina. So,
I am with you,
sino po?
Dr. Bagus, no, on this concern. Very big concern. Meron po tayong batas, hindi po nagagawa. Pero yung batas po kasi natin, nagsasabi, kailangan gawin mo in triplicate. Yung isa sa'yo, yung isa sa farmer, yung isa sa dispensing tapos ipapasa niya balik 'yun sa sa ating regulatory authorities. Napaka-tedious. Kaya sinasuggest nga po namin, marunong techie na naman ang mga veterinaryo, nandito tayo sa isang online na webinar, na maging online na rin po ang pag-submit ng VDO1 VCPR kasi gano'n na rin po yung ginagawa sa ibang bansa. So napakabilis nung sistema. Actually, ang human counterparts po natin, naka-attend po ako ng isang session, in-invite ang PVMA noon, ako ang nag-represent. They were trying to have an online prescription system then in place. Di ko alam kung nagagawa na siya, but definitely, I am with you on this concern. And sana po, pagtulungan natin, pag sinabi sa atin na ito na yung sistema natin, sumunod po tayo lahat. But for now po, paper format po muna. Try po natin gawin. If you need copies of the format, meron na po kaming sinadjust. Yan po.
Okay, thank you. From Dr. Agnes, question, is there a way to restrict access to antibiotics among farmers? Some farmers don't even have access to vets, but almost all poultry supply stores dispense antibiotics. So poultry supply staff aren't even trained most of the time.
Totoo yan. Si Ian, estudyante ko yata to. Ian. Totoo yan. As in, problema talaga natin yan. Paano natin i-restrict? Kasi even nung nag-survey kami no, sa PCSP, talaga yung access to antibiotics kasi paano natin pipigilan? At hindi lahat nga ay may consultant. So, I am with you in this concern. Sana maayos natin.
Okay, from siguro we'll take just one more question. No? So from Dr. Joseph Dian. So thank you, Doc. Question niya, strict implementation of no prescription by license. Ay, sorry, comment pala to. No dispensing of drugs.
Agree.
Yun, yan, inspired. Talagang madami, no? So ako na lang, last, yung siguro ang question na lang. Do you think we are going the right direction in the Philippines in terms of antibiotic control or preventing antibiotic resistance?
We are going in the right direction in the sense that nasa step 1 pa lang actually tayo. Ang dami pa nating kailangan gawin. Definitions pa nga lang, hindi pa tayo harmonized. Kailangan nating i-follow at makipag-usap sa mga human counterparts natin para yung mga listahan natin, yung ating mga guidelines ma-set in place. So, as in terms of direction, Doc, ang dami na kasi nating pwedeng gayahin na examples. So, hindi na tayo dapat naliligaw. Kailangan lang na upuan, gawin yung policy, and then i-implement yung policy, i-monitor na nagagawa yung policy. And kaya naman tayo nandito, kaya natin sinishare yung mga natutunan natin para maintindihan ng lahat na ito pala yung mga dapat gawin. Para pag nagtanong na o magpapasurvey tayo, maraming mga sumama para marinig din yung boses nyo. Para sama-sama tayo sa steps na gagawin. So, tamang direksyon. Ayun po. Salamat, Doc.
Okay, thank you, Doc Roselle, and thank you everyone who's sent in their questions. If you have any other questions, please continue sending them, and I'm sure Dr. Roselle would be very glad to answer them. So thank you very much, Doc Roselle.
Thank you.
Thank you very much, Dr. Cudal, for your very detailed answers to our attendees' questions. And as a sign of gratitude, the PVMA would like to present this certificate of appreciation. The Philippine Veterinary Medical Association presents the Certificate of Appreciation to Dr. Roselle F. Cudal for imparting her knowledge and insights as a speaker in the 89 PVMA Scientific Conference and Annual Convention, given this 14th day of February 2022 at Cristina Villas Mountain Resort in Antipolo City. Signed, Dr. Bernard B. Basic, Convention Chairman and PVMA Vice President and President-elect, Dr. Pag-asa B. Curaming, PVMA Secretary, and Dr. Paulino C. Abad, PVMA President. Thank you very much, Dr. Roselle Cudal, for always being there for your PVMA family.